Welcome back to the Digital Testing Suite, everyone. I'm your master coach, and today we are absolutely destroying Cambridge AS and 8-level mathematics topic 5.5, the normal distribution. If you look at the real-time tracking grids on your screen, you'll see our custom mark yield meter ticking up, measuring performance from those lowest foundational bands all the way to a clean, undisputed A star. Today, we aren't just doing superficial math review. We are decoding the exact structural frameworks and specific answering strategies demanded by Cambridge Assessment International Education to secure top-tier mark bands under intense exam pressure.
Right, let's look at the absolute stakes here. Did you know that topic 5.5, Mastering the Normal Curve, Standardization and Probability Evaluation, accounts for a massive 15% of your total marks in the Math 9709 examination? Seriously, let that sink in for a second. For a standard 75-mark paper, we're talking about 11 to 12 marks purely dedicated to this one specific syllabus area. That 15% is literally the mathematical threshold between an average, middle-of-the-road grade and a world-class top-tier result. It's an absolute high-stakes priority, and today we're claiming every single one of those marks.
Okay, let's dive right into this. Here is our strategic blueprint for today's session. We'll start by unpacking the 15% prize, move into mastering core theoretical foundations, break down the technical methodology step by step, tackle critical analysis and evaluation, expose the top 3 examiner warnings, and bring it all home with the ultimate recap. Section 1, the 15% prize. Let's get into exactly why this weight shifts our entire exam strategy.
Listen, when a single topic carries a 15% payload, the chief examiners are not just looking to see if you can blindly plug numbers into a calculator. No way. Capturing this prize requires you to prove causal relationships and map out incredibly clear, bulletproof structural frameworks. The Cambridge rubrics strictly dictate that to access those highest mark bands, your reasoning has to be impeccably logical. Let's break down the assessment objectives, or AOs, because this is where the game is won or lost. At the absolute baseline, you have AO1, simple knowledge and understanding. That gets you the first couple of marks. But to secure that full 15% yield, you've got to scale up to AO2, which is applying your math in totally unfamiliar contexts, and ultimately AO3, which demands high-level analysis and critical evaluation. This brings us to a massive pitfall: command words. If a question says calculate, you find the number. But if it says analyze, you need to break the mathematical relationship into parts. If it says evaluate, you literally have to judge the validity of a statistical claim based on your normal distribution data. Misinterpreting these command words triggers an immediate, devastating marking penalty on the examiner's grid. We simply cannot let that happen.
Section 2, Mastering Core Theoretical Foundations. Let's look at exactly what you need to memorize. Okay, I want to bring in 2 of our revision avatars to show you how this plays out in real life. Imagine we're in our shared study suite. We have Scholar 1, let's call him Alex. Alex is brilliant at memorization. He overloads his paragraphs with raw factual definitions, racking up AO1 marks, but he struggles with deep analysis. Then we have Scholar 2, Sam. Sam is a blazing fast writer who constructs highly persuasive arguments, but completely misses the explicit restrictions set by the examiner's command words. So they're looking at a standardization problem. Alex immediately writes down the theoretical architecture, defining n of mu, sigma squared, as the normal distribution baseline, where mu is the mean and sigma squared is the variance. Then he drops the gold standard standardization formula, z equals x minus mu over sigma. But Sam jumps in, wait, we're rushing. The principal examiner reports explicitly warn that candidates constantly lose marks here by failing to define the context first. And Sam is completely right. And this brilliantly illustrates our core rule. You must strictly define x as the random variable representing your specific real-world context before you even touch the z formula. If you don't define the terms you're standardizing, your structural foundation collapses on step 1, and the examiner stops awarding method marks. Our avatars, Alex and Sam, start debating this exact point. Alex just wants to list the textbook data inputs and move on. But Sam fights to build a flexible analytical thesis link to unlock those top-tier bands. Sam points out that the syllabus disproportionately rewards top-performing students who exhibit connected conceptual understanding that transfers to entirely unfamiliar contexts. For example, if a paper blends topic 5.5 normal distribution with a binomial approximation question from another chapter, that's where the elite marks live. Alex realizes he can't just operate in a silo. The global reports literally state, candidates referencing cross-topic connections achieve significantly higher marks. You aren't just solving a localized math puzzle. You are acting as an elite curriculum architect, showing the examiner that you see the entire matrix of the A-level syllabus.
Moving to Section 3, Technical methodology step by step. It is time to execute.
Now we transition into the practical execution phase. This is how we tactically process a problem to extract maximum points under extreme time pressure. I want you to internalize this standardized 5-step procedural sequence. Step 1. Deconstruct the question. Circle the command words and contextual limits. Step 2. Extract data. Pull out your mu and sigma. Step 3. Select framework. Are we finding a probability, or are we working backwards from a probability to find a z-value? Step 4. Execute. Run the math cleanly. Step 5. Present correctly. Anchor it back to the real world. Let's watch Alex and Sam run this. The question is, the weights of apples are normally distributed with mean 150 grams and standard deviation 12 grams. Calculate the probability an apple weighs more than 170 grams. Alex wants to just punch 150, 12, and 170 into the calculator's distribution mode. But Sam stops him. No, we have to follow the matrix to secure the examiner's goodwill. They extract the data. They write down the z-score framework explicitly. They execute the formula step by step, and they present the final probability clearly. Skipping even one of these structural steps leaves you totally vulnerable to marking penalties.
So the crucial point is heavily emphasized right here on the screen. We have to compare the incredibly risky just finding the final answer approach, which is exactly what Alex was trying to do, with the highly rewarding method mark strategy. Examiners award the highest, most consistent marks for your systematic process and clear notation, not just the final number. Think about your marks per minute formula. If you spend 3 minutes jumping to a final decimal and you fat finger calculator button, you score an absolute 0. You've wasted time and bled marks. But if you explicitly write out the standardization step, showing the examiner, hey, look, probability that z is greater than 170 minus 150 all divided by 12, you lock in those method marks immediately. Even if your arithmetic slips later, you've banked the points. That is how a pro takes an exam. Section 4, Critical Analysis and Evaluation. Let's move to and see how this builds into actual evaluation. Strategy check. Before we unlock this top band paragraph structure to help you absolutely crush your upcoming sessions, make sure your revision feed is perfectly optimized. Take a second right now to subscribe to Ace the Exams. That's at Ace the Exams, and enable all notifications so you never miss our weekly Cambridge exam breakdowns, no matter if you're sitting for IGCSE, O-levels, or AS and A levels. All right, you see that subscriber icon transforming into a ringing bell on screen? Perfect, you're locked in. Back to the study suite. Alex and Sam have hit a massive structural roadblock mid-paragraph. They've done the math, but the final command word was evaluate, and their evidence is failing to link back to the main thesis. This is where I step in as the coach and deploy a universal structural matrix, the PEEL framework. Point, evidence, evaluation, link. High-level evaluation, those coveted AO3 marks, requires identifying limitations and assumptions. In our Apple example, the normal distribution assumes continuous data, but practically scales of rounding limits. So Alex and Sam rewrite their text out loud line by line. They write, while the normal model provides a probability of 0.0475, evidence, this assumes weight is perfectly continuous, evaluation. Given physical scale limitations, this theoretical estimate may differ slightly from observable farm yields. Link. Boom. Flawless, top-tier response block. Section 5, Top 3 Examiner Warnings. It is time for our interactive visual workshop. I am addressing you directly right now. Welcome to the Pause and Practice workshop segment. Look at the data on your screen. I am putting a 60-second countdown timer on the screen right now for Challenge 1, the visual data scan. Your job is to extract the highest-yielding core trend from these global examiner reports before the clock runs out. Ready? Scan it. Okay, time's up. Now, what's really interesting about this slide is that the core trend, the top 3 mistakes, are entirely avoidable formatting errors, not mathematical ones. Let's move to Challenge 2, Spot the Examiner Trap. Imagine a medium-tier paragraph where a student calculates a z-value and writes, therefore, 93% of the apples are heavy. Where does the mark drop? I'm using my digital highlighter on the screen right now, right there, on the word heavy. The math is fine, but the answer isn't specific to the context. Heavy isn't defined. The presentation fails. The proper format requires saying, therefore, the probability of an apple weighing less than the specified threshold is 0.9332. Context is king. To absolutely immunize yourself against these top examiner traps, you need to engineer a custom memory hack. You need a rapid mental compliance audit that you run before you finalize any extended exam response. Let's call it the FCP audit. Formula, context, presentation. Before you drop your pen, ask yourself, F. Did I clearly write out my standardization formula to secure method marks? C. Did I link my final probability statement directly back to the actual context, like the weight of the apples, or did I just abandon a naked decimal on the page? P. Is my presentation clean? Are my workings clearly annotated? Running this rapid FCP compliance audit takes literally 10 seconds, but it acts as a permanent shield for your hard-earned grade.
Section 6, the ultimate recap. Let's distill everything we've built today.
Let's look at our avatars, Alex and Sam. They've reviewed their final high-scoring response text, and their personal breakthrough is clear. They successfully merged Alex's exact factual definitions with Sam's deep, context-driven analysis. For you, this translates into 3 universal Cambridge operational rules. Rule 1, the 3-step question scan. Decode those command words instantly, extract your variables, and master those 15% foundations. Rule 2, the marks per minute formula. Deploy the method mark strategy by writing out every procedural step. Don't rush to the final answer. Prove your analytical depth to the examiner. Rule 3, the post-writing compliance audit. Use your FCP memory hack to audit for the top examiner traps. Anchor your presentation to the context and explicitly state your assumptions.
So the ultimate question remains glowing on your screen. Are you ready to apply these cross-topic connections and flawless structural frameworks to absolutely conquer unfamiliar exam contexts? You now possess the exact architectural blueprint of what chief examiners demand in Topic 5.5. It is time to take action. Subscribe to Ace the Exams at Ace the Exams. Click that notification bell so you never miss our weekly grade masterclasses. And right now, I want you to drop a comment below sharing exactly which Cambridge subject and level, IGCSE, O-Level, AS, or A-Level, you are preparing to conquer next. Dive into those past papers, trust the matrix, and I will see you in the next masterclass.